Yeah, welcome to today's class. Today's class is about gravitation. So this is age-old topic actually, and in this chapter, I am going to cover all the topics that are related to gravitation. First time it is in second century, a scientist by name Ptolemy. He said that Earth is at the center. All the other planets, including Sun, is moving around the Earth. That was the first theory stated by Ptolemy in second century. And it was believed for 1400 years. For about 1400 years, this theory was simply believed. What is the theory? It is named after him, called as Ptolemaic theory. It is also called as geocentric theory. Earth at the center and all the planets, including Sun, is moving around Earth. And later on, in 16th century, Copernicus, a scientist by the name Copernicus, he has put forward his theory, saying that it is not Earth at the center, it is Sun at the center. All the planets, including Earth, is moving around Sun. And it's named after him, called as Copernican theory. It is also called as heliocentric theory. Today we all know that heliocentric theory is the true theory. Today it is Sun which is at the center of the solar system. All the planets, including Earth is also a planet, isn't it? Moving around the Sun. So this is the theory actually. So later on, Kepler, Johannes Kepler, proposed his theory, his laws, three laws of universe we call them, right? And these three laws, which are called as law of orbit, and law of area, and also about the law of periods. These three laws supported Copernicus theory, saying that it is Sun at the center. All the planets, including Earth, is moving around Sun. And in a course of time, we come across so many other facts of gravitation. The one among them is, see, it is like Earth is moving around itself, okay, going around itself. That we call it as rotation. And the time taken for one complete rotation, complete means starting point and ending point is same. It takes 24 hours. We call it as a day, right? In the same manner, Earth takes 365 1 by 4th day, 365 days and 1 by 4th day means 6 hours to complete one revolution around Sun. Means what do you understand? Suppose say, as you all know, Sun is at the center of the universe. All the planets, including Earth, is moving around Sun. So you take Earth for example here. Starting point is here. To come back to the same point, Earth takes 365 1 by 4th day. 365 1 by 4th. 1 by 4th day. Do you know what is the meaning of 1 by 4th day? Yeah, it is 6 hours. So we don't count these 6 hours actually. See, Earth doesn't know that after every 4 years, it has got one extra day to make revolution. Nothing like that. Earth takes same time for every revolution. Every year it takes the same time. 365 1 by 4th day. This 1 by 4th day means it is 6 hours. In order to develop a calendar, almanac calendar, right? Those days, people thought it is better we remove those 6 hours from each year, and 6 four is 24. That means after 4 years or fourth year, okay, they tried to add all these 6 hours and made it a day, and they kept that day in February, and it is kept as February 29. So what do you understand by this? Tell me. Every year Earth takes the same time to complete its revolution, 365 1 by 4th day. That means it takes just 365 days and 6 hours. We don't take those 6 hours into consideration for every year. Instead, what do? We calculate it for fourth year. 4 6 4 are 24, and we say that it is 366 days, which is called leap year. Some students are born in leap year. Say 2000 is a leap year, 2004 is a leap year, 2008 is a leap year, 2012 is a leap year, then comes 16, then 20, then 24. So it's so simple that after 4 years. Suppose a person is born in leap year and happened to be February 29, he should celebrate his birthday on 1st March, because every one of us is born in the revolution, one revolution, right? I am born in 73, 1973 means I am born in that 73 revolution, 1973. The earth has one revolution, isn't it, to complete its 1 year. So I am born in that one. If suddenly it happened to be a leap year and I am born on February 29, this February 29 is man-made. It's not celestial movement. Earth takes 365, 1 by 4th day to complete its revolution. Where from this 29 has come? We ourselves, right, calculated every 4 we removed, and every once after 4 years we placed a day inside February and said that it is February 29 is a leap year. As such, we don't have anything like that, okay? But okay, to some extent, since it is going on, we follow it. Now that is one part I want to tell you. The other thing is, every body is pulling the other body towards its center. This is what Sir Isaac Newton says. And you know the interesting thing, moon also pulls earth towards its center. Moon is also pulling earth towards its center, but we don't experience that one. The reason is what? Earth massive in mass, a huge body of mass Earth is. So that force of attraction that is exerted by moon on Earth is not seen. Then what happens? Do you think moon will keep quiet? No. Moon has got some acceleration towards Earth, and on particularly on full moon and new moon. Okay, what happens? Do you know? You will get high tides. This cause of high tides is due to the attraction of moon towards earth. Moon is trying to pull earth towards its center. In this process, what happens? Do you know? Water which is present on the earth is attracted, due to which we get tides. So very interesting, isn't it? This is what you call by acceleration of moon directed towards earth, and it is 0.0027 meter per second square. So now in this lesson, we are going to calculate all this. We will come to know how you got that value 0.0027 meter per second square. Like that, so many other concepts are there. Newton law is there, right? Newton law says that F is proportional to m1 m2 by r square. So where from did you get this law? Force of attraction is directly proportional to product of the masses and inversely proportional to square distance between them. So where from did you get this? Now we will try out, okay? Then next one is what I told you, that all the planets including earth is moving around sun. So when a body is, according to physics I am telling you, when a body is made to move in circular motion, that means I took a stone, I tied that stone with the help of rope. I caught hold of this point. I caught hold of this point and I started applying force. I started applying force like this. I caught hold of this point and I started applying force. When I apply force and when I catch hold of this point and apply force, automatically there is a force which is directed from this object towards the center, makes the object to move in circular motion. Okay, this force which is directed from this object towards the center makes the object to move in circular motion. This force which is directed towards center, we call it as centripetal force. Centripetal force. Suppose you are making the object to move in circular motion with applying force. At any point, let me take this point only, okay? You suddenly remove this force. Means you left it, you let it go. Turning, you let it go. The moment you let it go, it will fly away like this. This is called centrifugal force. So what actually I want to tell you is so simple, that when an object is moving in circular motion only, you will come across these two forces. When an object is moving in straight line motion, suppose say I take a ball and I tie it with rope and just I leave it like this, it will fall straight to the ground. No problem. If I catch hold of the point rope and start applying force like this, then it makes circular motion. Why does it make circular motion? Because there is a force directed towards the center. As long as I catch hold of this point, what happens? Can you tell me? Object moves in circular motion. The moment I am turning it, the moment I remove that force, automatically ball is thrown away from the center. That we called as centrifugal force. And once again, let me tell you, these two forces come into action only when the object is moving in circular motion. If an object is moving in rectilinear motion or a straight line motion, how can you expect these two? No. Okay, so it's understood now that planets are also moving in circular motion, so they should exhibit this centripetal and centrifugal force. So F is equal to ma. Centripetal acceleration is v square by r. We'll see how you will get this v square by r. From there our derivations, everything will start, right? Now we will see our normal acceleration. The formula for normal acceleration is v minus u by t, rate of change of velocity. Now what did I say? We are speaking about bodies moving in circular motion. Means we are speaking about celestial bodies, bodies which are moving around sun and all that. They may not be moving in a circular motion, that's understood, but they cover an angle of 360. You know, pi means it is 180. 2 pi means how much it is? 2 into 180, therefore it is 360. Whatever it is, either elliptical or whatever it is, they are making revolution, isn't it? Therefore they cover an angle of 360. Therefore now I want to calculate it. Velocity is equal to displacement. This is a displacement vector, okay, displacement by time. Since we are speaking about object moving in circular motion or elliptical covering an angle of 360, therefore it is 2 pi by r. 2 pi r by t, sorry. Therefore t is equal to, come on, cross multiply, t is equal to 2 pi r by v. Okay, understood. Next one is what did I tell you? Let us now know what is the centripetal force acting towards the center. Centripetal force means centripetal acceleration. Centripetal acceleration. Acceleration means what? Velocity by time. What velocity it is? 2 pi v by t. But already you know t is equal to 2 pi r by v. Let us substitute at the place of t. So it is 2 pi v by 2 pi r by v, which is centripetal acceleration. So 2 pi and 2 pi gets cancelled, and v by r by v, so reciprocal, it is v into v by r. Therefore the formula of centripetal force is, centripetal acceleration is v square by r. Now you got it. Centripetal acceleration is AC is equal to v square by r, right? Now, so you got it as centripetal acceleration as v square by r, right? Okay, done. Now next is what? Acceleration of moon. Let us calculate acceleration of moon with the same formula. It's now understood, v square by r. So what is v square? Displacement by time. Just now I told you, no, 2 pi r by t. That means it is square because it's v square. By r, let us write it as 1 by r. Now what happens? What has it become? Am is equal to 4 pi square, 2 square is 4 pi square r square by t square, okay, 4 pi square r square by t square, okay, into 1 by r. This r and this r gets cancelled. Okay, what is left over now for your am? Am means what? Acceleration on moon. It is 4 pi square r by t square. So what is 4 pi? 4 only. 4 pi square. It is 22 by 7 into 22 by 7 into r. R is, you know, the distance between earth and moon, and it is 384,400 kilometer, right? It is 384,400 kilometer. But what happens? I want to know the acceleration on moon in meter per second square. Therefore, let me remove this kilo. Kilo means another 3 zeros. Okay, by time square. Moon takes, do you know interesting thing about moon? Moon takes 27.3 days to complete one revolution around Earth. As you know, moon is a celestial, what do you call, only natural satellite to Earth. Moon is moving around what? Earth. So moon takes 27.3 days, almost a month. In a month it makes one round, complete round, okay, revolution. But another interesting thing is what? 27.3 days it is taking. Means almost 3 days left over. Almost in a month, 3 days left over. 12 threes are, it is 36. That means moon is making 13 rounds in 1 year. While Earth is making only one round around the sun, that we call it as 1 year, 1 year. Whereas moon is taking 13 rounds, making 13 rounds around Earth. Where do you find this logic? Tell me. Actually, from my birth, my childhood until now, I know there are only 12 months in a year. Only in case of recharge, we'll find 13 recharges in a year because they give recharge only for 28 days. Why? Because they follow this revolution of moon time. Moon takes 27.3 days to complete one revolution. Interesting thing, isn't it? Right. So, moon takes 27.3 days to complete one revolution around Earth. So, each day has got 24 hours, each hour has got 60 minutes, and each minute has got 60 seconds. So, it is second. Okay. And what else it is? T square, it is T square. So, it is second square. So, you are calculating acceleration. You are calculating acceleration of moon. If you do all this, okay, you will get an answer called 0.0027 meter per second square. You will get this value. This is what acceleration of moon directed towards Earth, which causes what? Tides. This is what the acceleration is. Moon showing this much acceleration towards Earth. Right? It want to attract Earth towards its center, but that is not possible. Therefore, it starts attracting water which is present on Earth and causes tides. This is what the acceleration is. Now, G on Earth, you all know, no, G on Earth is how much? It is 9.81 meter per second square. Nothing but what's in, right? You can convert this also into centimeter. It is 0.27 centimeter per second square. So let us convert this also into centimeter. It is 981 centimeter per second square. So if you can divide AE, acceleration of Earth directed towards moon, by the acceleration of moon, that means what is it? 981 by 0.27. If you can divide these two, you will get an answer which is quite approximately equal to 3640. Remember this value, 3640. Right? When you divide this, what acceleration of Earth directed towards moon and acceleration of moon directed towards Earth. So I have calculated all this. Now coming to this, according to that one, radius of Earth, do you know? It is 6371 kilometer. This is the radius of Earth. This is the radius. This radius is 3671 kilometer only for Earth. And this is moon, isn't it? The distance between from the center, okay, the distance between Earth and moon is 384,400 kilometers. Just now I said, isn't it? So let us take that as RM. It is 384,400 kilometer. Now, if you can divide RM by RE, that is how what you can tell you, 3,84,400 kilometer by 6371 kilometer, you will get an answer approximately 60.4. Right. Is it 3640? No, it is not 3640. What you got is 60.4. So let us square this and see. RM by RE, if you can square it, that is approximately 60.4, isn't it? If you can square it, you will get an answer 3640, approximately 3640. What did you notice? Can you tell me? Actually, this answer is obtained by AE by AM. Isn't it? AE by AM, you got this answer 3640. Now the same thing you got it for what? RM by RE whole square. So what do you understand by this? These two are inversely proportional. Therefore, from this we say that A is proportional, inversely proportional to R square. See, you got it when it is R squared only. You got this answer when it is squared. Therefore, A is inversely proportional to R square. That means what does it mean? F is equal to Newton's second law. F is equal to ma. Okay, let us take it as proportional because I am not taking the constant. F is proportional to ma, or else what can you tell me? F is equal to k is a constant, m by r square it is, right? What do you understand by this? Can you tell me? What do you understand by this? I told you, no, Newton's law. F is proportional to m1, m2 by r square. Yeah, it is satisfying this law. See, r square is inversely proportional. Masses are directly. Interesting, really. Super, you can say. Super way he has derived and showed that your force of attraction is directly proportional to product of the masses and inversely proportional to square distance between them. Isn't it excellent? Now, taking this into consideration, you got this law. F is proportional to m1 m2 by r square, where F is equal to G m1 m2 by r square. Now, what do you mean by this capital G? It is called universal gravitational constant, and it is stated by whom? Sir Isaac Newton. Right? As you know, Sir Isaac Newton's story. One day he was sitting under an apple and apple fell down, and he said that it is all due to gravitational force, and in the course of time, right? And this acceleration directed towards acceleration of moon directed towards earth is also calculated by Sir Isaac Newton. He said that it is how much? Do you remember? 0.0027 meter per second square. This is also done by Sir Isaac Newton. And finally he said that these type of force exist on all the celestial bodies that are present in the universe. Therefore he called it as universal gravitational constant, and he has given a value for the universal gravitational constant, capital G. It is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is the value of universal gravitational constant. Okay, right. G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So now what is the formula you got? F is equal to Gm₁m₂ by r square. Now what, right? And F is equal to Newton's law, it is Gm₁m₂ by r square. Okay, where G is called what? Universal gravitational constant, 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Now we'll see how did you get this unit. How did you get this unit? Newton meter square per kg square. So F is equal to Gm₁m₂ by r square it is. Cross multiply G is equal to Gm₁m₂. Hello, cross multiply Gm₁m₂ is equal to Fr square. I want only G, isn't it? So I don't want m1 and m2. So by m1, m2, it will go denominator. It remains as it is, Fr square by m1 into m2. What is F force? It is force. Unit for force is Newton. What is R square? It is distance. So it is meter square. What is m1? Mass. What is m2? Mass. So kg into kg, kg square. This is how you get the unit of capital G, universal gravitational constant. Okay, these units are obtained like this. Okay, now we'll speak about other factors. So just now I showed you the acceleration of moon directed towards earth with the formula 4 pi square r by t square, isn't it? 4 into pi means 22 by 7 into 22 by 7, where r is what? Distance between earth and moon, that is 384,400, right, kilometer. By time, moon takes 27.3 days to complete one revolution, into 24 hours, into 60 into 60. Okay, and I converted 3,84,400 kilometer into meter, and I got the answer as 0.0027 meter per second square. That is what acceleration of the moon directed towards earth. We all take G on earth is small g, that is gravitational force on earth, as 9.8 meter per second square. But do you know how did you get it? Right, there is a formula to calculate small g, that is a universal gravitational force. not the constant. Constant is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. I am speaking about small g, that is gravitational force of Earth, which is considered as 9.8 meter per second square, and we can even take it as 10 meter per second square. How do you get it? That is our today's. Now I am going to derive it, because I have derived, centripetal force means v square by r. Since you know it v square by r, then only you got the other formulas. Same way now. F is equal to what? F is equal to, it is Gm₁m by r square. So there are two masses. One mass is bigger, so capital M, while other one is smaller. But we all know, no, F is equal to ma. Nothing but A is nothing but G, because we are speaking about gravitation. So acceleration is changed into gravity. So at the place of F, let us substitute that one. So it's mg is equal to Gm₁m by r square. So this m and this m gets cancelled. Therefore, you got the formula as G is equal to Gm by r square. This is the formula used to calculate gravitational force. Even this is the formula used to calculate gravitational force on moon. Everywhere, this is the formula. Okay, G is equal to Gm by r square. Now, what is your capital G? Now we are going to calculate a gravitational force on Earth, which is 9.8. Now we are going to see. G means it is 6.67 into 10 to the power of minus 11, where m is mass of Earth. Okay, mass of Earth is 6 into 10 to the power of 24 kg by, this is radius of Earth, it is 6.4 into 10 to the power of 6 square meter. It is meter. Okay, once again let me tell you, this G is universal gravitational constant, and the value is 6.67 into 10 to the power of minus 11, where m is called mass of the Earth. Why? Because you are going to calculate G on Earth. So mass of Earth is 6 into 10 to the power of 24 kg. And what is r? Radius of Earth? It is 6.4 into 10 to the power of 6 meter actually. So it is r square. Right, very good. Now, what is this one? 10 to the power of 24 minus 10 to the power of minus 11. This part is finished. What is left over? 6.67 into 6 by 6.4 square. 6.4, okay, it's squared into a to the power of m into a to the power of n is a to the power of m into n. Therefore, it is 12. Okay, right. Now what happens, 6.67 into 6. So 6.67 into 6 is 40.02 into 24 minus 11. So it is 10 to the power of 13 by 6.4 square. It is 40.96 into 10 to the power of 12. So small g is equal to 40.02 into 10 to the power of, what is left over here? 13. So you bring this 10 to the power of 12 top. So it's 10 to the power of minus 12 by 40.96. Therefore, what is left over? G is equal to 13 minus 12 is 1. So it is 40.02 into 10 to the power of 1 by 40.96. So 40.02 into 10, you get it as 400.20 by 40.96. What do we do with small g? We say it is 9.8 meter per second square, or else simply we say approximately 10. Do you know why we say 10? See, it's 40 ones are 40 tens are. Understood. Or else if you want exactly, if you want to remove that point, because after point 2 digits, here also after point 2 digits. Therefore 400 and 20 by 4096. If you really divide this one, you will get the answer as 9.77 meter per second square. I don't think all those who are watching this one, I don't think you have ever calculated small, that is gravitational force on Earth is 9.8. Oh, most of the time from since 6th class foundation onwards, we are always taking G as 9.8 meter per second square, and never you might have calculated. This is the actual formula. This is how we get G as 9.8 8 meter per second square, because this is approximately 9.8 meter per second square, or we even call it as 10 meter per second square. So every problem what we do on gravitation, whenever we come across small g, we say it is 9.8 meter per second square, 10 meter per second square, right? How do we get it? This is the formula. G is equal to, small g is equal to Gm by r square, where g is called universal gravitational constant and m is called mass of the earth, which is 6 into 10 to the power of 24, and r is radius of the earth, which is 6.4 into 10 to the power of 6 meter. Okay. Now coming to gravitational force on moon. See, many of us make mistake. If I am 60 kg on earth, how much will I be on moon? The moment you ask this question, many students will say it is 10, because from our earlier classes we are taught like that. What is that? If you are 60 kg on earth, if you are on moon, if you are taken to moon, there we are 1/6. Therefore 10 divided by 6 is equal to, sorry, 60 divided by 6 is equal to 10 kg. So immediately, spontaneous, you will get the answer as 10 kg, which is absolutely wrong. How can mass vary from place to place? Mass can never vary from place to place. What varies, do you know? It is gravitational force. Now, if I just now I showed you G is equal to Gm by r square is a formula used to calculate gravitational force. The same formula is used for moon also, calculating gravitational force on moon. On earth, gravitational force is 9.8 meter per second square. On moon, this 9.8 divided by 6 is 1.63. See, on earth, the gravitational pull is 9.8. On moon, this pull is 1 by 6th. Please try to understand, it is not mass. If I am 60 kg on earth, on moon also I will be 60 kg only, because 60 kg is a unit for mass, and mass does not vary from place to place. Then what varies? Pull. That pull varies, gravitational force. On earth it is 9.8. On moon, this 9.8 is divided by 6. So it is 1.63. Now I will show you. See, the same formula. G is equal to Gm by r square. Now what is capital G? Universal gravitational constant with this value, isn't it? 6.67 into 10 to the power of minus 11. What is m? Since you are calculating for moon, it's all about moon, okay? It's about moon. So mass of the moon, right? Mass of the moon is 7.35 into 10 to the power of 22 kg. It's written here. Okay, done. Then what else next? It is radius of the moon, right? The radius of the moon is 1.737 into 10 to the power of 6. And what else it is? What else? Squared. So if you take these values and try, as I have done it for earth just now, right? What you need to do, 22 minus 11 is 11. This 6 2s it is 12. You take 12 on the top, and everything if you do, then you will get the answer as 1.63 meter per second square. This is what gravitational pull on the moon. What do you understand? Where did you get it? On earth it is 9.8 meter per second square. If you can divide this by 6, okay, you will get this answer, 1.63 meter per second square, and which is on moon. This is on earth. So now tell me, where is a chance for me to reduce my mass? My mass everywhere remains same. Everywhere mass remains same. It is mass which does not vary from place to place. It is only the pull that varies from place to place. Okay. So on moon it is 1.63 meter per second square. Now we will see variation of G value. Do you know G value, as I said just now, it is mass which does not vary from place to place. Then what varies? It is gravitational pull varies, man. It is gravitational pull. That is small g, gravitational force of attraction varies. On earth it is 9.8. If you divide this 9.8 by 6, whatever the answer you get, it is on moon. This gravitational pull, isn't it? It varies. You know how much it is on sun? It is 27.4. Means almost 3 times that of Earth. Imagine. That is the pull. On Jupiter, it is almost 10 times greater than Earth. That is what you mean by gravitational force. It is not mass which varies. If I am taken to Jupiter, my mass will remain same 60. Right? And other thing, do you know, mass is different from weight. There's a lot of difference between these two. Mass is completely different from weight. My mass, if my mass, suppose I want to collect 2 kgs of sugar. If I want to collect 2 kg of sugar, what I am saying is mass. Kg is mass. It cannot be weight. Do you know the formula of weight? It is W is equal to mg. What I am saying, 2 kg sugar should be multiplied with 9.8. Then I get an answer called 19.6 kg meter per second square. That is the actual weight. We don't take anything, groceries or whatever it is, we don't take by weight. We collect them by mass because it becomes difficult for the shopkeeper to understand. Even he may be educated or uneducated. Suppose you go to a shop, since you know weight means formula is mg, so you want to purchase 2 kgs of sugar, so you are multiplying that 2 kg into 9.8 because the formula for weight is mg, where m is a part of the formula, that is 2 kg sugar you want, that should be multiplied with 9.8, then the answer is 19.6. What is here is mass kg, what is here is gravity, that is meter per second square. Imagine anybody is using like this. You have to go to a shop and say, if you want 2 kg sugar, you have to say, give me 19.6 kg meter per second square sugar. He will get shocked. He will not allow you to come to his shop again, isn't it? So we are not calculating by weight, but weight, it is like this. Why are we not calculating by weight? Because mass everywhere remains same. Whether the shop is on the 10th floor or on the first floor, gold shops, whether it is on 10th floor or first floor, it is mass. You are purchasing mass. Therefore, it does not vary from place to place. What varies is weight. Okay. Now, we'll see other things. Now we will see variation of G. As I was just now telling you, there is a variation in G value, not mass. So why? Because you see the formula. G is equal to Gm by R square. So it's very clear. These two are inversely proportional. Right? Gravitational force is inversely proportional to radius. So now when you take the earth, this is earth, okay? This is called pole. This is called equator. Now you tell me, where do you find radius more? At the equator. At the equator. So as you go up towards pole, what is happening to radius? Decreasing, isn't it? I know radius is half like this, it is understood, but I am explaining in a different way. So it's like this. So it is become shorter, it is becoming shorter. That means at equator, R is maximum. So G will be minimum. Why? Inversely proportional. So at pole what happens? R is minimum. R is minimum. So there G is maximum. Right? Same way if you go deep, if you go to height, G value decreases. Remember at height, G value decreases. Right? If you go deep into the mine, deep into the mine, you go deep into the mine also, G value decreases. Why? That is due to effect in the mass, we say, effect in the mass. M is equal to 4 by 3 pi r cube rho. This is the formula to calculate effective mass. And there are formulas to calculate what gravity at height. Gh is equal to G into 1 minus 2h by r. This is the formula to calculate at height. G at height. G at depth, G is equal to G into 1 minus d by r. This is the formula used to calculate gravitational force at depth. This is the formula used to calculate gravitational force at height. Whether when you go up above the earth, okay, G value decreases. If you come down, G value increases. But if you go deep into the mine also, G value decreases. So if you go up, decreases, deep into the mine, decreases. But when you come towards earth from up, G value increases. Why it decreases at depth? That is due to effect in the mass, 4 by 3 pi r cube rho. This is what you mean by variation of G. So in 2nd century, Ptolemy said that it is Earth at the center, all the planets including Sun is moving around Earth. This theory was believed for 1400 years. Blindly people believed this theory thinking that Earth is at the center. Later on in the 16th century, almost 1400 years later, Copernicus, he said that it is not Earth at the center, it is Sun at the center. All the planets, including Earth, is moving around the Sun. It took 1400 years to say this one. Nobody believed Copernicus immediately, right? He has gone through number of experiments. He has done number of experiments to prove that it is Sun at the center. And today we all know it is Sun at the center. And this particular theory proposed by Copernicus, it is also named after him, called as Copernican theory. It is also called as heliocentric theory. Later on, Johannes Kepler, he proposed 3 laws of universe: law of orbit, okay, law of area, and law of periods. These 3 laws gave strength to Copernicus theory. But interesting thing, do you know? These 3 laws are proposed by Kepler to support Copernican theory, saying that Sun is at the center. Done, very good, successful. But to prove these 3 laws, John S. Kepler faced a lot of problem. So these 3 laws were mathematically proved by Sir Isaac Newton. See the interesting thing? Kepler tried to explain that Copernican theory is correct, that Sun is at the center, and today also we know Sun is at the center. So for this he has proposed 3 laws: law of orbit, okay, and law of area, and law of period. But what happened, tell me? He could not prove it. He stated the laws but could not prove it. They later on, Sir Isaac Newton mathematically proved that Kepler's laws are correct. What do you understand by first law? Orbit law. Do you know orbit law? Yes. Sun is at the center of the universe, we say, isn't it? That is wrong, he said. It is not center of the universe. Meanwhile, other planets, when you speak about other planets, they are moving in this type of shaped orbit, okay? This is a shape of an orbit, elliptical. And this shape, okay, is called as ellipse. Ellipse means what, you know? Major axis and a minor axis. Now when you divide this, okay, when you divide this particular thing into 2 halves here, this is called point of focus. Point of focus. Now if you divide this into 2 halves, again here, this is called point of focus. Okay? So he is saying that law of orbit says that the Sun is never at the center of the universe. Never. It is at one of this focal point. Focus point. It is at one of this focus point. Now when you say like that, we may think that course of time it is here and the course of time it is at the other focus point. That is again wrong. See, Sun is not found at the other focus. Never. Sun is not found at the other focus actually. Why, you know? For example, I take a rubber band. Say this is the rubber band I took. So this part I fixed. I kept a nail. Imagine I kept nail like this and I caught hold of this point. So very close to this is called focus. So I stretched it up to here. Okay, this let me take it as planet and let us take our own planet Earth. So it's like this here. Now I stretched it up to here and now I want to continue this shape as it is. Like this I want to continue. I'll show the other side. Right? Because right, it's like this. So see, this point, fixed point is here. Only thing what happened, tell me, I took this to the other side. Okay, where is my Earth now? Here. When you look at this position, what do you understand? Can you tell me? You feel as if there are 2 focus points. Where is that other focus point? No. Only thing I pulled it to the other side. So this point remains as it is. That is why it is understood that very clearly that it is not at the center. It is not at the center, that's all. It is at one of the focus we say. It depends upon. You know another interesting thing. Suppose a planet is very closed. See, this part is over. I'm taking diagram for the next one. Area. If the planet is very close to the sun, it moves fast. You know, its time period is fast. If the planet is far from the far, see this is far, suppose far from the, if the planet is far from sun, if it is far from sun, its movement will be slow. Its movement will be slow. Do you know that one? Right. So perihelium and aphelium we call. Perihelium means it is close. This part, this is very close. Perihelium. Here movement of the planet will be very fast, very fast. Aphelium means what? Planet is far from the sun. Here when it is far from the sun, aphelium, you know the movement of the planet, it will be slow. This is what you mean by Kepler's law. Okay. Second law is what, you know? Law of area. That means he's saying, exactly speaking, sun is not at two focal points, isn't it? It is only at one focal point. So this area, whatever the area you take, okay, either here or here, if you say planet is here, this area, right, remains always equal. This area always remain equal from the sun. That is what you mean by law of area. Simple thing it is. That area, that part of the area is always same. Now coming to the third one is very interesting. Okay, and it has got a derivation also. Third one has got a derivation. A very interesting law. Law of period. He says that time period is directly proportional to cube of its radius. T square is proportional to r cube. Because this law has got the strength. You know what does it mean? If the planet is too far from the sun, okay, its time taken for revolution will be more. See, Earth takes, one second, clear, let us be clear. Earth takes 365 days, 365, 1/4th day to complete one revolution, starting point, coming back to that point. 365, 1/4th day. Do you know about Jupiter? Right? Jupiter takes 10 years to complete one revolution. 10 years, 10 years to complete one revolution. So suppose say this is a sun over here, sun, and here Jupiter is here, starting here. Suppose Jupiter want to come back to the same position, that we call it as revolution. And it takes 10 years to complete one revolution, Jupiter. Whereas our Earth, it takes just 365 days. Just 365 days. Where is 365 days and where is 10 years? If you think about Neptune, because you know what comes first, one is Mercury, then comes Venus, then comes Earth. So we are speaking about our Earth. Then comes the other planets. So you are speaking about Jupiter. Neptune, which is a bit far. You know how much time does Neptune take to complete one revolution only? Just start from here. Start from here and come back to this point. It takes 165 years. 165 years to make only one revolution. Just to make one revolution, start from here, come back, it takes 165 years. Tell me now. Jupiter takes 10 years to complete one revolution. Our Earth takes just 365 days. That is 1 year. Earth takes 1 year to complete revolution. Jupiter takes the same 10 years it takes to complete same revolution. Neptune takes around 165. What do you understand? I'm telling you now, the strength is with this law. This law clearly explains that time period depends upon the radius of the planet from that. That means nothing but distance from sun to that planet. Right? This is what it is. Now we will derive Kepler's third law. A very interesting law. Very interesting law. T square is directly proportional to r cube. Newton's law, force of attraction, F is equal to Gm₁m by r square. So what happened now? Let us take that F as centripetal force. So it is mv square by r is equal to Gm₁ by r square. Let me write it capital, okay? No problem. That doesn't make any difference. So now let me cross multiply mv square into r square is equal to Gm₁ into r. Done. Okay. Now what is it? I want only v square. Therefore Gmm by what is left over here? Mr square. This r and this r gets cancelled. This m and this m also gets cancelled. What is left over? V square is equal to Gm by r. I get this formula. Therefore, V is equal to applying square root on both sides. This remains as it is Gm by r. Okay, I got this one. What do you call this? V is equal to root Gm by r, you know. This is called orbital velocity. This is a formula for orbital velocity. But actually velocity is what? Velocity is equal to displacement by time. What displacement? 2 pi. 2 pi, because we are speaking about celestial bodies moving in circular motion. 2 pi indicates 360. Therefore T is equal to what from here? T is equal to 2 pi r by V. Therefore T is what? 2 pi r by V. V is this one, isn't it? So it is 2 pi r by root Gm by r. Why did I write this root Gm by r? Because V, it's already stated here, right? I told you in orbital velocity, root Gm by r. So I substituted. Now this part, I'll take this r to the top. T is equal to 2 pi r into root r by root Gm. You know the calculation of this one? I'll tell you. R into root r is nothing but what? R into r1 by 2. This is 1. Okay, r1 by 2. I'll write it like this so that you will understand. This is according to what? A to the power of m into a to the power of n is equal to a to the power of m plus n. So let us do the same thing. 1, it is 1 here. 1 power is 1 plus 1 by 2. So LCM is 2. Then it goes here 2. 2 plus 1 is 3. Therefore, it is 3 by 2. So I got it. This is only to show you that r into root r is equal to r3 by 2. So I am doing the same thing now here. Okay, done. It is 2 pi r 3 by 2 by root Gm. Okay, done. Now I want to square this. T square is equal to, so it is 2 pi r 3 by 2 square by root Gm. So what happened? Tell me. 2 square is 4 pi square r 3 by 2 is how much? I'll show you here. 3 by 2 into 2 it is. So it is 6 by 2. Your answer is 3. This I have done it. It is like a to the power of m to the power of n is equal to a to the power of m into n. So I have done it. So I got it 3. Therefore it is r to the power of 3 by, so root Gm. So when you square it, it gets cancelled and you get the formula Gm. This is what you mean by Kepler's third law. You got it. Let us do problems on the same lesson, gravitation. So given a problem, car is moving with the constant speed 10 meter per second. So given velocity or speed is given, speed 10 meter per second. Okay, in a circular path of radius is given 10 meter. Okay, done. Mass of the car is also given 1000 kg. What is he asking you to calculate? Centripetal force. So you remember F is equal to ma. I am just deriving it. You need not do that one. You can simply write formula for centripetal force is m is equal to v square by mv square by r. But I am telling you, you remember a is equal to v square by r. Therefore, you get this formula mv square by r. And this is no more force. It is now centripetal force, Fc. Right, very good. So, done. Substitute. What is mass given here? 1000. into what is the velocity given 10, so it is 10 into 10 because it is v square, my radius is 10, so 110 gets cancelled. 1 2 3 4 4 zeros, 10 to the power of 4, or else you can write after 1 4 zeros. What is it? You are calculating force, therefore it is Newton. This is the answer. First problem is over. Let us see the second problem. The problem is like this. A ball is projected vertically up. So ball is projected vertically up. So these type of things is kinematics actually. V is equal to U plus AT, H is equal to UT plus half AT square, and V square minus U square is equal to 2AS. These things we have shifted into gravity. I have done a video on this, on these equations, how these values change when A is replaced with G. Okay, a V is equal to U plus or minus GT, H is equal to UT plus or minus half GT square, V square minus U square is equal to 2GH. I'll put the link. Okay, you can refer that video. Right, very good. So when the body is projected up, you find U is equal to U and V will be 0 at this maximum point, and while going up G is negative. So there are three questions in this question. In this particular question, sub questions are there. The first one is find the maximum height is saying. So given, what is given first of all? It is told that a ball is projected vertically up. So U is U and V is 0. So whatever the velocity that is given, it is U. Therefore U is given as 50 meter per second. Now he is asking you to calculate maximum height. Maximum height for the H is equal to U square by 2G. So on base of this type of thing, I have done a video. Please you can refer back. So U is given as 50. So 50 into 50 it is, by 2 into, as you know, G value is 10. So 10 ones are 10 fives are, and 2 ones are and 2 25s are. So 25 into 5 is 125 meter is the height. Then he is asking you calculate time taken to reach this maximum height. That is called time of ascent actually. T1 is equal to U by G it is. So it is now U is already understood, it is 50 by G is 10. So your answer is 5 seconds. And the third question is speed at the maximum height. You can check it out here. Speed at the maximum height is V is equal to 0 meter per second. So I have finished problem number 2. Get ready for problem number 3. This is the problem. Two spherical balls. Okay, given two spherical balls are given. So given two spherical balls of mass 10 kg each, it is each one is 10 kg. So M1 10 kg and one more ball is M2 which is also 10 kg. Good, okay, done. Placed with their centers 10 centimeter apart. So radius is 10 centimeter. This is an interesting thing. Problem actually is it is here. Everything should be in the same system, but this is in CGS. Therefore, you divide this by 100. Your answer is 0.1 meter. Okay. So you have to convert this into meter. That is very important. Find the gravitational force of attraction. So he is asking you to find F. F is equal to G m1 m2 by r square is your formula. Now he did not ask you to take universal gravitational constant value, that is 6.67 into 10 to the power of minus 11 Newton meter square per kg square is not necessary. Therefore it remains as it is G. M1 is how much? 10 kg. M2 is how much? 10 kg. M1 is 10 kg, M2 is 10 kg given here by R square. R is how much? 0.1 into 0.1. So G, it's already 10 into 10 is 100. Now what happened? Tell me. After point 1 digit is there. So let us make it 1. So it is into 10. Again after point 1 digit is there. Therefore let us make it 10. Therefore your answer is G into 10, 1, 2, 3, 4 zeros, 10 to the power of 4. And you are finding what? Force, sorry. Therefore it is Newton. G into 10 to the power of 4 Newton is the answer. Now let us do the fourth problem. This is the fourth problem. A ball is dropped from the height. A ball is dropped from the height. So let us draw the diagram. Ball is dropped from certain height. So remember, it is a freely falling body. For a freely falling body, u is 0 meter per second, and v will be v. So right, he is telling that time taken by the body for last 6 meters to travel this last 6 meters. Hello, this is last 6 meters. Time taken by the body to travel for this last 6 meter is 0.2 second. Right? Now he is asking you to find the total height. Very interesting problem and very easy also. One thing let me tell you clearly. See, initial velocity for a free fall is 0, but already he is asking you to do the problem here. You are supposed to start the problem here. First, you have to start the problem at this area. Remember, everybody remember, you have to start the problem at this area. Right? And you will come to know what is u here. From here it is u for this last 6 meter. So the problem goes like this. Given, what is given? Time is given 0.2 second. Last height is given 6 meter. Okay, and what else? G is asked to take as 10 meter per second square, and your u will be u. First here u will be u. So you may be understanding that u is 0, isn't it? Why sir is taking u is u? Problem is here. When you drop it from here, it is initially 0, but it is traveling already. When you speak about u here, u will be u here. Okay, right. So these are the values. H is equal to ut plus half gt square is your formula. Given h height is how much? 6 meter is given. U, just now I told you, no, u is u. T is given as 0.2 second. T 0.2 second plus half. G is 10 into T, time it is given as 0.2. So it is 0.2 into 0.2 because it is T square. Therefore it is 6 is equal to 0.2 u, it is u. It's not 4, okay, it is u plus 2 ones and 2 fives are. Therefore it is 5 now. On the top it is 5, okay, 5 into 0.2. So you make it 2 by 10 into this 2 by 10. Okay, so now 5 ones are, 5 twos are, 2 ones are, 2 ones are, 2 ones are, and 2 it is 5s are. Therefore what did you get now here? Yeah, come on, next. 6 is equal to 0.2 u, 0.2 u. So let us remove that pointer. Okay, so it is 2u by 10. This part is over. What is left over here? 1 into 1 into 1. It is just 1 by what is here? 1 into 1 into 5. Therefore it is 5 here, 5. So LCM is how much here? 10. So 10 goes in 1 time, so 2u plus 5 goes how many times? 2 times, therefore 2. Cross multiply, it is 60 is equal to 60 is equal to u, it is u plus 2. So let 2u be as it is, 2u. You send this 2 to the other side. So it is 60 minus 2 is equal to 58. Then 2u, isn't it? So u is equal to by 2. Your answer is 29 meter per second. You got u now. This u, what you were thinking u, okay, it is now 29 meter per second. Now when you do the problem for this part, now you're doing the problem for this part, second phase. Okay, when you do the problem for that part, whatever u you got, this will turn into v. This is v for you. Why? Because u is u, isn't it? It's dropped from top. You started from here, you did up to here, and you got something like u 29 meter per second. That is the logic in this problem. Whatever you got u, okay, that way when you do the problem from here to here, it's like last v. So from here to here, this will be v. So whatever u you got, it will turn into v. Whatever u you got, it will turn into v. That's all. So the formula is now v square minus u square is equal to 2gh. What is v? 29 square minus 0. Your u is 0. You are doing this part of the problem. Is equal to 2 into 10 into h. You don't know h. You are trying to find h only. This h only. So 29 square is how much? it is 841. So some part of it let me rub. That's okay, understood, right? Very good. So 29 square is what? 841. 841 is equal to, right? 2 into 10 into h, it is 20h. Therefore, h is equal to 841 by 20, right? So you get an answer as 42.05 meter. Now total height means total height. You have to find total height. No, 42.05 plus you are doing problem for last 6 meters, isn't it? So plus 6. You get the answer as 48.05 meter. This is how this problem is solved. You got the answer. Thank you.